Okay, guys, I'm not even gonna. From here on out, I'm just gonna just let you know. You'll just assume that when things end wackily, without me saying it's the end or whatever, it's technical issues. So it happened again. So in the previous video, I was at this point, and I was going to jump over into R. So let me do that and show the illustrations. I tell you, it's getting QuickTime's starting to piss me off if you want to know the truth about it. But and I've looked into seeing if I can reinstall it, and that's more difficult than what it should be. But anyway, gang, what we want to do here is we want to get the sum of squares between, and that's by taking the sample size and let me take a look at this. So we want to look at the with sum squares between here. So we want to look at the variation between the tutors. So we're going to look at the group means minus the grand mean for each tutor, and look at the summation of that times uh, the, the number of scores or observations for each tutor. So the first thing I would want to do is the grand mean, and I'm just going to call it this. And I want the mean of these score. Okay. Next thing I want to do is my group mean. And so I want to do, let's just do T apply. And I want to do score over tutor. And I want to do the mean. Now, what I should be able to do now is I want to take the sum of 8 times the group mean minus the grand mean. I don't even know if this is going to work or not. Squared. And that's hard to say because I don't know what we're supposed to get. I'm pretty sure that's what we need to get because it. Well, I set up exactly the summation that we need. So. So guys, we have 554 here. So at the end of the day, here's what we've got. We know that the sum of squares total was let's see. Okay, there it is, 1706. And this is the total amount of variation that we need to explain. Okay? This is what we currently know. The variation across the repeated measures was, let me go through some papers here, what I wrote down, 1603. Of the 1603, we have 554, was it? Yeah, okay, 554, yeah. We had 554 that was explained by the experimental manipulation. Right, variance within tutors. So that leaves 1603 minus 554, which is 1049, right? Memento arithmetic here. Yeah, okay. As the unexplained variation. So in the previous video, I tried to talk about the how the unexplained variance could be kind of the some of the variance across the repeated measures can be seen as the sum of two parts. And when we're doing repeated measures, there's that extra component there that we can explain through the experimental manipulation. But in this case, there's still quite a bit, 1049, that goes unexplained. Our ratio is going to be a little over 1 or 2. Well, I don't know. This is going to be a close one. I don't know whether we're going to get experimental or whether we're going to get statistical significance or not. Anyway, guys, this right here, our degrees of freedom is n minus k minus 1. So let's make some calculations. We're ultimately going to let R do some of this, but I want you to know more than just how to punch buttons on R. So F is the mean squares for our model over the mean squares for the error. And I started out calling that mean squares between and within on purpose. And of course, this is into two components. This is the sum of squares for our model over its degrees of freedom, sum of squares for the error over its degrees of freedom. For our problem, the sum of squares for the model turned out to be, that for the experimental manipulation was 554. Its degrees of freedom was k minus 1. And the unexplained was 1049. And that would be n minus k minus 1. So what is that? That's 32 minus 32 minus 8 minus 1. So it's going to be 21. All right, let me get my calculator and make that calculation real quick. And I get 3.70. So in our F distribution, degrees of freedom 321. What's the area to the right of that? Well, that's going to be easy to use R. So we're going to go 1 minus PF. And I want 3.70, comma 3, comma 21. So this is 0.028. So when we jump out of here and get into R, that should be the calculations of our model. I'll tell you what, let's just go ahead and do that. So